Next we'll see some multiplexer problems. So suppose you want to convert say an 8 by 1 mux. You want to create an 8 by 1 mux using 4 2 by 1 mux ICs and 1 4 by 1 mux. Suppose this is the question. So you know what the 8 by 1 mux truth table is. So this is your question. Okay. So 8 by 1 mux will have 3 select lines. Output will be from 8 lines. And 1 1 1. So 0 0 0 will be I0, I1, I2, I3, I4 is selected, I5 is selected, I6 is selected and I7 is selected. So this is your truth table for 8 by 1 mux. This is what you need. So if you need this, what do you have? You have 4 2 by 1 mux ICs and 1 4 by 1 mux IC. So always write 0, 1, 2, 3, etc. in the multiplexer input line. Do not write it as continuous 0, 1, 2, 3, 4, 5. Don't write like that. You can write that in the case of input line. So here you can write I0, I1, I2, I3, I4. Like this you can write. I5, I6 and I7. That you can write. Here you have a G dash, G dash, G dash. So actually these G dash, all the G dash should be shorted and connected to a logic 0. But in order to simplify the circuit, in order to not complicate the circuit, I'm not shorting it. I'm just giving a logic 0 everywhere. Actually these are shorted and given to one switch, and that switch is kept at the low position. Okay. So now what do we need? We need 0 0 0, I0 should be selected. So here you have say Y1, Y2, Y3, Y4. So by now you must be knowing that these Y1, Y2, Y3, Y4 is what is connected to these lines, just like in the case of the 4 by 1 mux using 2 by 1 mux ICs, just like that. So one of the output lines of the 2 by 1 mux is selected using the 4 by 1 mux. So you can write 2 by 1 mux inside each of these. Due to space constraint, I am not able to write. So you can write inside 4 by 1 mux, 2 by 1 mux in each of these. Okay, so now we need to know, here you have two select lines, here you have one select line, here one select line. So I need to know what are the select lines, which is A, which is B, which is C. That is what I need to know. Okay. So this, you can see that I0, I1 is in the first, I2, I3 is in the second, I4, I5 is in the third, and I6, I7 is in the fourth. So I0, I1, I2, I3, I4, I5, I6, I7. So these are the 4 ICs. So here if you see what is common in these two, in the first mux, what is common? A0 is common, or even more, AB is common. Both are 0, 0. Here AB is 0, 1. Here AB is 1, 0. And here AB is 1, 1. So depending on the value of A and B, one of the output lines is selected. So this will be AB. Yes. Now depending on the value of C, I0 or I1, I2 or I3, that is selected. So this is C. Actually all the select lines are shorted and given to a switch, and that is kept as C. You have only one select line. Since this is a big circuit, I am not shorting all the lines. I am just showing it as C. When you do it in the lab, you are actually shorting all the 4 select lines and giving it to a single switch, and that will be taken as C. So you have A, B and C. So if you see A0, B0, C0, A0, B0 means Y1 is selected, C0 means I0 is selected. So I0 will come to Y1, C0 means here I2, I4 and I6. But only Y1 is selected since AB is 0, 0. So Y will be I0. Likewise, you can see 0, 1 means 1 is selected, 1, 0 means 2 is selected, 1, 1 means 3 is selected. Likewise, in the value, if C is 0, I0, I2, I4, I6 is selected, 1 means I1, I3, I5 and I7 is selected. So this particular truth table is solved. Yes. Now next, another problem which can come is function of ABC equal to sigma m, something like this. So if you see this, the largest number is 6. So this can be implemented using a mux. Which mux do you require? You require a 8 by 1 mux. Okay. Since you have 3 select lines, you need an 8 by 1 mux. But the question is, implement this using a 4 by 1 mux. 8 by 1 mux is not given. Okay. So if it is 8 by 1 mux, you just need to draw an 8 by 1 mux, connect these lines to 1, the rest of the lines to 0, give strobe equal to 0, you can get the output correctly. That we have already done. But if you want to use a multiplexer, other than 8 by 1 mux. Here you need 4 by 1 mux. So in the case of 4 by 1 mux, you have only 2 select lines. So here you have 3 select lines. So what will you do with the third select line? So when you get a question like this, there are two methods by which you can do this problem. First method, I'll do the long method, and secondly I'll do the shortest method. But the long method you should know, because it is from the long method that you are getting to the short method. So in order to understand the concept, I'll tell the long method first, then we'll go on for the short method. So what do we know? The select lines are A, B, C. My output is Y. So that will be 0 to 7. Five, 6 and 7. Now Y will be 1 for these. So 0, 3, 4, 6. Others, the answer will be, the output will be 0. So this is my truth table. This is the truth table which I need. This is the truth table which I need. But I have only 4 by 1 mux. So in the 4 by 1 mux, I have only what? 2 select lines. So in such cases, what you can do is, of the 3 select lines, you can either eliminate the MSB or the LSB. Don't eliminate the other literals, other select lines. It is easier to eliminate the either the MSB or the LSB. Okay. So I'll tell one method. Next method you can automatically understand. So suppose I'm eliminating the LSB. Okay. So C I'm going to eliminate, means, okay. So I will be taking only A and B. So in my this is my 8 by 1 mux. And in my 4 by 1 mux, I have only 2 select lines. And this is my output. Okay. I'm given only a 4 by 1 mux, but I need the truth table of an 8 by 1 mux. So 4 by 1 mux means it is 0, 0, 0, 1, 1, 0 and 1, 1. Yes. So what we'll do is, we'll see A0, B0. Wherever we have A0, B0, we will take. So in the first 2 lines, first 2 rows, you have A0, B0. Okay. See, I'm not looking at. Then you have 0, 1. So A0, B1. Next 2 lines you have that. 1, 0, A1, B0. And this is A1, B1. Okay. So A0, B0 means these 2 cases. A0, B1 means these 2 cases. A1, B0 is these 2 cases, and A1, B1 is these 2 cases. So when A0, B is 0, what is Y? Y is 1 when C is 0, and Y is 0 when C is 1. So how is Y related to C when A0, B0? You can say that Y is equal to C complement. So you can write here as Y equal to C complement. Whatever is C, complement that, you will get the Y. So you have to see the relation between the eliminated select line and the output. So 0, 1 means these 2 cases. C is 0, Y is 0. C 1, Y is 1. So Y is equal to C. So here it is C. 1 0, again C complement. Here again C complement. So here it is C complement. Here it is C complement. Okay, so that is how you will be getting the truth table for the 4 by 1 marks from the 8 by 1 marks IC. Okay, so now I have this. This is what I require. I don't need this. From this I got this. Okay, so using this I'll draw. So I have a 4 by 1 marks. This is a 4 by 1 marks. So in this 0, 1, 2, 3, this is G bar. G bar is equal to logic 0. Here you have two select lines A and B. Okay. So A0, B0 means what is Y? Y is equal to whatever is in the 0th line. So what should be there in the 0th line? C bar should be there. So C will be an input and C bar will be the NOT. So C bar will be given to 0. 0, 1 means you have to give C. Two is again C bar. 3 is again C bar. Okay. So this is how you get. So A0, B0, C0 means what should I get? A0, B0, C0 means I should get a 1. So A0, B0 means 0th line is selected. C I am giving 0 because 0, 0, 0 is what I am taking. C0. So 0 will get a 1. So Y will be 1. Then you can see whether 3 I am getting a 1. So 0, 1, 1. 0, 1 means first line is selected. Here I am giving a 1. So that 1 is given to 1. So I'll get a 1. 4, if I see 1, 0, 1, 0 means 2. 0, C is 0. So C bar is 2. So that will be 1. 6, 1, 1, 0. 1, 1, 0. 1, 1 means 3. 0. So here 1. And in 3 it will be a 1. So Y is equal to 1. You can check the zeros also. 1. Suppose 1, 0, 0, 1. 0, 0 means 0th line. 1 here means 0. So you will get a 0. Likewise, you can check the entire 8 by 1 marks truth table and see whether you are getting the answer for every single step. Okay. You have to check whether you are getting it for every single step. If the procedure is correct, then you will automatically get. But that's how you do in the lab. Now, in this case, I eliminated the LSB. So when I eliminated the LSB, you saw that you were grouping 0 and 1, 2 and 3. 4 and 5, 6 and 7. Corresponding numbers I was grouping of ABC. Okay. So that is 0, 0, 0, 0, 0, 1 I was grouping. 0, 1, 0 and 0, 1, 1 I grouped. 1, 0, 0 and 1, 0, 1 I grouped. 1, 1, 0 and 1, 1, 1 I grouped. Okay. So next we will go for the simpler method. you need to use only that. But then how do we reach there? That is from this long method. So what I'll do is, I'll just draw a table like this. Okay, so now I need to use a 4 by 1 mux. So in the 4 by 1 mux, whichever select line I'm eliminating, that I'll write here. In this particular case, I'm eliminating C. So C can take two values, 0 and 1. So I'll write the 0 first. C0 means C bar and C1 means C. Then I'll write the 4 by 1 mux. 4 by 1 mux has 4 input lines. So that I'll write from I0 to I3. Okay, I'll write all the input lines. Next, what I'll do is, if you are eliminating the LSB, which all numbers did you group? 0 and 1. So those numbers I'll write vertically. 2 and 3, 4 and 5, 6 and 7. These are the numbers I grouped. The numbers which you grouped, you will be writing in the vertical columns. Okay, that is A0, B0 means I0. A0, B1 means I1. A is in the 4 by 1 mux. A1, B0 means I2 is selected. A1, B1 means I3 is selected. So, for that, 0, 0, 0 is 0, 0, 0, 1. So, A, B, 0, 0. That's how we do. Now what we do is, this is my question, 0, 3, 4, 6. So these numbers I will just circle, 0, 3, 4, 6. After circling, I'll compare the numbers in vertically. So if there is only one circle in a vertical column, whatever value is there corresponding to that circle, I'll write that. So here it is C bar. Here 3 is circled, which corresponds to C. Here it is C bar and here it is C bar. So my truth table from this is AB, Y. AB 0, 0 means I0. So that is C bar. 0, 1 means I1, that is C. 1, 0, C bar and 1, 1, C bar. This is the truth table which we got in the earlier case also. But now we got it in 2 steps. It's very easy. Okay. So just write the multiplexer, whatever multiplexer you need, those input lines you will be writing, whatever value, select line you are eliminating, that you will write, but don't write it as C bar, you will get it wrong. It should be C bar C. Then circle the values in the SOP, that bracket, min terms. Then write the corresponding value. Now suppose both are circled in a vertical column, both are circled. That means if 0 is there and if 1 is there, both case the answer should be 1. So you will write as 1. Both circled, answer is 1. Both not circled, that is in a particular column there is no circle, nothing is circled, then that is a logic 0. Okay. So then using this you can draw like in the earlier case. So this is another type of question. So using this technique you can do many questions. So whenever you need a 8 by 1 mux, you can settle for a 4 by 1 mux if you reduce it like this.